This is Math 6, Lesson 1-2, Estimating with Whole Numbers. Compatible numbers that are numbers that are easy to compute mentally. Estimation is used when it's most advantageous. You want to estimate to make your math easier, not more complicated. To estimate, you select numbers that are close to the exact numbers, but are easier to use for computing. Normally, you round to the nearest 10, 100, or 1,000, or at least round to something like 50s, 75, 25, something that is easy to add or subtract mentally. It is helpful to use estimation for many different reasons. For example, let's say you have $10 and you're going to the grocery store and you want to buy some certain items. It's very embarrassing to get up to the clerk and she rings up your order and you find that it's $12.18 and you're $2.18 short. Then you have to figure out which items you want to put back, and the people behind you start to grumble because you're slowing them down, and you're just a wee bit embarrassed because you don't have the money to cover your bill. But if you estimated as you were going through the grocery store, rounding probably all of your numbers up slightly, then there's a good chance when you get to checkout you will not end up not having enough money. That is just one of the times when estimation is helpful. It's also helpful to estimate when you don't have to have an exact answer. If somebody says, how many people attended the movie? And you say, oh, around 75. They don't need to know exactly how many people attended the movie. Sometimes we need to know, well, we're going to charge everybody 50 cents that went to the movie. Well, then we need to know exactly how many people went to the movie. But if we want to just know, was this a popular movie or not? Yeah, 75 people attended the first showing of this movie. That's a pretty popular movie. This is times when estimation is helpful. One of the ways we can estimate is to estimate by rounding. When you estimate by rounding, you normally round all your problems to the same place value. You round all to the tens or all to the hundreds or all to the ones, unless you have a complicated set of numbers in which that's impossible to do. Let's take a look at the numbers that we have here. We're going to estimate by rounding. 47 plus 72 plus 58. Yes, you could probably add these in your head pretty easily. However, we're working on estimation, not on basic addition. So I'm going to say 47, 7. I'm going to round this. Remember, when you round, if a number is 5 or greater, you round up. I'm going to round all these numbers to the nearest 10. So 47 is going to round to 50 for me, 72 is going to round to 70, and 58 is going to round to 60. Then all I have to add is 6 and 7 and 5. Okay, 6 and 7 is 13, plus 5 is 18, so this is approximately equal to, that's what this little symbol is that I just wrote, 180. These two little squiggly lines is the approximately equal to symbol that you use when you're not giving an exact answer. Equal sign means exact. Two of the squiggly lines that look like the equal sign kind of got waves in it is approximately. So if you need an approximate answer, you use the approximately symbol. If you use an exact answer, you use the equal symbol. When you're doing subtraction, you can do the same thing. I have 94, 32, and 41. I'm going to round all of these. They all have numbers in the tens place, so I'm going to round them all to the tens position. 94 would round to 90, 32 would round to 30, 41 would round to 40. So if I'm going to subtract these, 9 minus 3 is 6, 6 minus 4 is 2. Okay, so I could do 90 minus 30 first and get this to be approximately 60, and then take 60 and subtract 40 from that, and I get it approximately equal to 20. Or I could think to myself, 9 minus 3 is 6, 6 minus 4 is 2. The answer here is approximately 20. I like to box or circle my final answers because that way it's easy for people to find and there's no question about what you wanted as your answer. The next way to estimate is with compatible numbers. Compatible numbers that are close. Numbers that are easy to multiply or divide in your head, that you're not going to have to use lots of paper and pencil. That's the whole point of estimation. You shouldn't have to be using great large amounts of paper and pencil to be able to figure out the answer. If you have to do a little bit of dividing off to the side, that's fine, but you shouldn't have to be doing, monumentally 3 pages of a division problem. If you're going to estimate with compatible numbers and you're doing division, you always look at your divisor first. The number doing the dividing is called your divisor. Always estimate this first. So I'm going to say 487 divided by 52. Well, 52 is closest to 50. Okay? So I'm going to take my division and make this 50. Now I want a number 487 that is easy to divide by 50. So I could go down to 450 or I could go up to 500. If I think about that, I have the options of doing 450 or 500. Which one is closer to 487? Okay, that's what I need to figure out. Is 450 or 500 closer to 487? Well, 450 to 487 is 37. 487 to 500 is 13. So 500 is closer to 487, so I'm going to take it round my number of 487 to 500. So these are now compatible numbers because 500 is easily divisible by 50. Okay? So if I think about it, 500 is easily divisible by 50. I can knock off a 0 for each one of these, so now I'm taking 5 into 50. 5 goes into 50 10 times, and the answer to this is approximately equal to 10. If I'm going to multiply, then it doesn't matter which number I round first. If I have a single-digit number, I probably should not round it, because single-digit numbers, if you're going to multiply, don't round up or down. My double-digit number does. So I'm going to leave my 8, and instead of multiplying it by 39, I'm going to round that 39 to 40, because I know that 8 times 4 is 32, and then all I have to do is add the 0, because multiplication by hundreds, powers of 0, 10, 100, 1,000, is very easy. So this is approximately equal to 8 times 4 is 32, add a 0. This would be a better estimate than rounding 8 to 10 and 39 to 40 and getting 400, because this is a better estimate. Number 5, again, we're going to do compatible numbers. Okay. Again, I'm going to look at my divisor first. Since it is a single-digit divisor, I'm not going to round it. I'm going to keep this divisor because it's single-digit. You don't want to round a single-digit divisor. So I'm going to take my 358 and I'm going to think 358. I need a number that is easily divisible by 9. Okay? So I'm going to think about this and I go 9 goes into 36, doesn't it? So it would go into a 360 really easily. So I'm going to round 358 to 360. So now I have 360 divided by 9. I know that 9 goes into 36 4 times. So it'll go into 360 40 times because it's 10 times bigger. So this is 40. That's what compatible numbers do for you. They make it so that you can divide easily in your head. I can divide 360 by 9 much easier than I can divide 358 by 9. So if I don't need an exact answer and I go, oh, it's around 40, that gives me a reasonable answer. Let's look at some applications, aka word problems. You have 324 cards for a strategy game. To play the game, a person needs 12 cards. About how many different people can play using your set of cards? So in other words, you need to know what's the greatest number of people that can play your game so that you have enough cards so they can actually play and have fun. So you have 324 cards, and you need to divide them up because each player needs 12 cards. Okay? So if I need 12 cards per person, it's probably best to round this divisor into something that I can divide pretty easily. Okay? Because, you know, I'm not really good with dividing by 12. Most people aren't. So I'm going to look at this and say, what's a good number that's close to 12? Well, 10 is. It only rounds it up, down a little bit. 324. Okay? I could round that down to 320 or 300. So I'm looking at this going, I could do 320, I could do 300. I'm going to go down to 320 because 320 is closer than 324. So now I'm going to take 320 and divide it by 10, and that's approximately 32. So approximately 32 people can play my game. Probably a little less because I rounded down, so I would probably round to say, 31 people can play my game. Because I might be a few cards short because I only went down 4 for 320 and I went down 2 from 10 to 12. So it might be a good idea to just say, okay, 31 people can play my game and I have a few extra cards. Since this is a word problem, we should write the answer as a complete sentence. All word problems need to have answers written in a complete sentence. So, to answer this question, this is how many different people can play using my set of cards. About 32 people can play. And there we have the answer. Again, box or circle your final answer just makes it a whole lot easier for somebody else to find. Last question. Each of the 29 students in Mrs. Wong's class read about 512 pages of a novel. About how many pages did they read in all? In other words, lots of reading occurred over the summer. So if she has 29 students, and they each read about 512 pages, we're going to do some compatible numbers here because it's going to make it so much easier. Okay, so 29 students, let's round that to 30 because 30 is easy to multiply by because it's got a 0 in it. 512 pages, let's round that down to 500. And we're going to multiply these two things together. A dot in mathematics is another way of saying multiplication. I prefer it to the multiplication symbol of an x because when you get into more complicated classes, an x is a variable. So I'm going to take 300 and I'm going to multiply it by 5, I'm going to take 30 and multiply it by 500. 3 times 5 is 15, and I have 1, 2, 3 zeros, so I have to add 3 zeros to my problem. It's an easy way to multiply by hundreds, tens, hundreds, and thousands. Multiply the whole numbers, count up how many zeros you have, add those zeros to the end. So they read about 15,000 pages. So how many pages did they read in all? They read about 15,000 pages. Notice, complete sentence and labeled. All word problems need to be written in a complete sentence. They always need to be labeled.